Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. I'm really so excited to have Charlie Reed. He's a partner at ATLANTIC-ACM. Charlie, welcome to Executives at the Edge. So excited to have you on this episode because we're going to talk about some really fascinating areas around connectivity, specifically what's driving connectivity, what's hot in connectivity. Is it carrier Ethernet, wavelengths, SD-WAN for overlays, IP, DIAs, and also how does AI play in all of this? So, Charlie, welcome to Executive at the Edge. And if you can just tell for our listeners a little bit more about your company and what you do, that'd be really appreciated.
Great. Thanks, Pascal. So great to be here. So ATLANTIC-ACM is a research and strategic advisory firm based in Boston. We started in the early 90s, a long time ago, focusing on analyzing, at that time, voice services or the services of the time, working for our carrier clients and some enterprise clients, really understanding in-depth market analytics and where the market's headed. We have grown through time. We made it through the dot-com bubble, and we've evolved to be not only an industry analyst firm, but also a strategic advisory firm where we advise investors and carriers making strategic investments in M&A and diligence. Our focus is really on the U.S. connectivity market. We also hit on other infrastructure elements such as towers, data centers, and we pride ourselves in our very, very in-depth sources of data and levels of analysis to kind of build up the market and provide concrete outputs that are data focused.
Well, thank you, Charlie. That sounds really, really good. Now, ATLANTIC-ACM has been doing this for quite a while, and you said you're focused on connectivity. So let's start there. So what are you seeing the demands from the enterprise? So they're all doing digital transformation. They all want to go to clouds. And they all want to go to their sites and their data centers. What is really going on there in connectivity? What's the demand by what kind of product line? Is it IP, carrier Ethernet, wavelengths, SD-WAN overlays? Can you help our listeners with this?
Yeah, sure. So, when you think about enterprise connectivity, it's connecting sites and connecting to the internet. And as we've seen over the past couple of years, there's been a big transformation in what these enterprises are needing to do their business. And I think underlying a lot of that is the fact that the applications are, has been talked about many times, are moving from the enterprise site to a lot of cloud and a lot of SaaS applications. And with that, bandwidth demand is increasing as well. And so to make the most efficient connectivity, there's been a movement to SD-WAN, and that movement changes the transport link. So that's kind of the products that you're talking about as far as where the demand is. And so enterprises are shifting from MPLS services. They've shifted a while ago from point-to-point private line services to really purchase more DIA and broadband connections, and then use the SD-WAN to kind of make the most of those connections through dynamic path control, et cetera. So the net effect is that enterprises are more efficient in how they run connectivity, and that's driving an overall decline in the spend on data services for just the enterprise group. But there is a lot of pockets of growth. I mentioned that in DIA, we're seeing really strong demand. Folks are focused on those SLA protected services and continue to buy more and more DIA connections, whether it's a movement from MPLS or just to support the bandwidth demand they need. Broadband is also another option, often for backup for the enterprise services. And then, to my point about the applications moving to the cloud and moving to data centers, we're seeing a lot of demand for really high bandwidth, 100 gig, 10 gig, 100 gig connections, and a lot of those are wavelengths, sometimes Ethernet services. So we see, big demand for those wavelengths, and in some cases for the larger enterprises, and particularly hyperscalers, which is kind of a different topic, you see dark fiber purchases. So, net, some pressure as these enterprises become more efficient, but definitely areas of growth in the internet space.
So if we can just break this down a little bit more, if I can just recap. So we started with the era that enterprises wanted MPLS circuits, IPVPNs.
Uh-huh.
That's kind of where we came from. Obviously we came from even more immature times, but obviously the IPVPN MPLS market was $40 billion, very large, and the carrier Ethernet market, which is a layer 2 market, is $80 billion, which includes services and product, of course. So those are very large markets. Now you're saying all of a sudden that's being moved aside and everyone wants to buy IP DIAs. And the reason is because SD-WAN has provided the same kind of performance capabilities and even availability that IPVPNs and carrier Ethernet gave, because the DIAs with SD-WAN overlays with DIAs underlays, those two together can really enable the same behaviors that what they were buying from. Is that first fact true or not?
Yes, I would agree with that. I think another key element is, the traffic and the applications, aren't between the enterprises, but again, in the cloud and SaaS. And so the fact that a lot of the info is coming from the internet, that kind of adds another factor to the SD-WAN as far as moving to kind of those DIA and broadband connections. And I think, that this whole transition is a little detrimental to the carrier revenue, just given the declines in MPLS and the fact that internet and those sort of service can be a little bit more commoditized. But I would say that, there still exists a nice opportunity for businesses that aren't just looking for the internet, but there is, cloud direct connects and specific connections, particularly ones that are dynamic in nature, that is a growing element of the private connectivity space. So, despite my notion that internet is taking over, there still is a key opportunity for really dynamic private connections, particularly to clouds.
But the DIA loop is so much inexpensive. So if many of these sites are going off MPLS or IPVPNs and even carry Ethernet, and they don't need that speed, but they need that performance guarantee, and now the SD-WAN is delivering over internet loops, that's cutting on the revenue of these service providers, isn't it? I mean, it's cutting to large volumes of massive amount of revenue that's now moving to a cheaper internet loop. Is that not a concerning issue for these?
I mean, it is, it is a concerning issue, and it is an element that has driven down the top line revenue for a lot of large carriers. That's not to say there's not a lot of opportunity in managed services in that SD-WAN overlay, et cetera. But, in the world of enterprise connectivity, it's a pressured time because of the dynamics that you just mentioned.
Interesting. And what about 5G? Do you see fixed wireless access of 5G being a predominant role? It's a broadband loop, so more for backups maybe, but slicing is potentially now coming in with 5G.
Yeah, I think that the role of wireless in data connectivity has obviously increased. The traction of fixed wireless in the business space is seen by, the numbers of Verizon reports is very strong, and we estimate the market in several million connections. And I agree that a lot of those are backup loops. And a lot of those are more small businesses, but enterprises are certainly utilizing that for backup loops and specific applications. That is a use case of the expanded network and the C-band networks. In the world of network slicing in 5G, that has not had a lot of traction or impact on the market. How we look at that going forward is that as the wireless carriers are able to really prioritize traffic, they can emulate some of those higher level wired connections that exist today. For example, like Ethernet access, we have not seen that prove out. I think their focus is on their cellular network, so it's unclear how much of an impact that will make. But certainly seen it pick up and take away some of the broadband connections. Not as much impact on DIA, Ethernet, etc.
So what about the idea of buying and selling the ecosystem? So carriers were interconnected, and they interconnect, and they were buying and selling the transports and interconnecting them. And now with this SD-WAN, are they utilizing more buying and selling of DIA loops? So for example, a corporation enterprise says, Mr. Service provider, you take care of my SD-WAN overlays, but I need, these sites connected all over the world. That service provider does not have the footprint for all over the world, so it partners for all these other providers and buys DIA loops, internet loops on behalf of the enterprise? Or does the enterprise go and supply their own DIA loops?
That is a good question, and maybe I'll back up and hit on what you said about the wholesale ecosystem. So, as many folks know, the carrier-to-carrier transactions are enormous, and wholesale is a very large market. And no matter how big your network is, many carriers require interconnectivity between other carriers in order to connect their customers. That's a big element of even what AT&T, Verizon, Lumen offer. And so when we think about MPLS, Ethernet networks, even DI networks, a large chunk, 30 to 40% of the connections are off-net or type 2. As we talk about this transition, there is going to be a bit less demand for off-net connections, I would say, because MPLS had a bigger role there. But, as these enterprises are buying internet services, they like to work with one carrier, and so there is a growing element of managed service providers such as like Nitel, Spectratel, those folks going around and sourcing DIA for their customers. Additionally, anytime the large carriers sell DIA, they often will do off-net, and the end user enterprise customers still like to work with one carrier. And so that wholesale market, while declining, still exists. And what the wholesalers are buying, historically they've bought carrier Ethernet for that last mile loop. They will still do that. But they are moving to buying what we would call resold DIA to some extent. It depends on how they like to manage their own traffic, whether they like to put the IP services over their own core or just buy a resold service. But we see generally speaking, the MSPs buy resold DIA, where the large carriers still buy that carrier Ethernet to connect their enterprises, regardless of what type of fiber product it is, whether it be Ethernet, MPLS, or DIA.
So Charlie, what about for higher bandwidth scenarios? For example, data center, or hybrid clouds. So private clouds of their data centers to public clouds. Doesn't that need much higher bandwidth? Also, that's probably where more carrier Ethernet and even wavelengths play a very traditional role. Do you see that's kind of more where the big bandwidth hungry kind of scenarios are more catered to that versus, you're not going to go for DIA?
Yeah, absolutely. So, as I mentioned, and as folks know, the amount of bandwidth that's traversing the nation is growing very fast. And what's enabling that are these large connections, that those connections are purchased by enterprises, or carriers purchase them from each other to, connect key POPs, key data centers, key enterprise locations. And the product that they usually utilize is carrier Ethernet or switched Ethernet service. Easily can do 10 gig, and that is a efficient way to do that. Obviously, there's movement within that Ethernet market up speed. Wavelengths, which are point to point and have a deterministic path and are a little more efficient for, say, 100 gig services or increasingly 400 gig services, are a growing market. That product's been around for a long time. We expect that market to grow kind of in the 5% range for the in the enterprise side, and that's growing rapidly, and particularly, we'll talk about some of the huge demand elements. But as you connect two data centers, or if you are doing a connection to, an AWS where you have tons of data housed, you're going to be likely to just buy a big wave service. And then I think another element that we talked about is dynamic bandwidth. Sometimes folks need to access their cloud resources, and it is either more efficient or more secure for them to provision a private connection as opposed to go through the internet. That is the minority of connections to the cloud, but that is an element that is stable, and we're expecting some growth. And folks like Megaport, Packet Fabric, and all the large carriers have a product that caters to that demand.
So what about AI? How does AI play out on all this in this bandwidth demand?
It's an interesting question that is still in the early phases, and I think it's timely, just given some of the statements that Lumen has made recently. So, when we think about AI, it's thrown around a lot, but focusing on the impact of the connectivity market and the overall general telecom infrastructure space, the biggest component is these training models. What is OpenAI and Meta and Google Alphabet? They have a demand, and they are building out huge data centers with tons and tons of power. A lot of those data centers are even in tier 2 markets where the power is cheaper, and they need to connect all those locations and move around tons and tons of data. And so they are investing heavily, essentially, building a national network. We saw Lumen just announced a $5 billion deal with a potential additional $7 billion that's kind of spread out over 20 years. And that demand is all dark fiber as it stands right now. Some of it will be a couple hundred gig waves, and that's going to have a positive effect on folks who own fiber, especially long haul fiber, or are builders of fiber. As we move forward, there'll be more what we call inference models. So those are enterprises building AI-driven applications, typically utilizing those large language models that the big guys built, to kind of be the new phase of AI. And it is to be seen what will be required from a connectivity standpoint. Folks that know they're going into this say, I'm not 100% sure what I'm going to need, but I know it's going to be a lot. So let's get some wavelengths set up. Let's see what this looks like. On the low end, it could be kind of like a Google search where you're just sending text back and forth from these models. On the high end, you could be a large, police, like medical. You may need to send your depository of your terabits of information into the model and back. And in that case, you would need huge amounts of bandwidth. So we'll be watching that. That could drive more private connectivity and really impact the market. I think our assumption now is it's going to be more, internet focused and not be a force multiplier on, say, waves and Ethernet market. But I think that'll be the one to watch when the inference models really take off. And I think that could be given the nature of the way the data interacts with those models, it could be a driver of some bandwidth on demand or some quick provisioning requirements. If you're an enterprise and you need to send your entire archive of your consulting work to the AI model to be interpreted, you might want to spin up a wavelength or some big circuits for a little while and then kind of spin it back down. And it could be a driver for that service, which hasn't had a huge. The up and down elements haven't been a huge demand, but it could drive some demand there. And then, way down the road, there's discussion about AI models talking to each other, and more, all machine to machine, as it relates to these large language models. I think that's early. We'll see how that plays out, but again, could drive, big connectivity infrastructure needs.
So it's really interesting that, at MEF, we're working for a network as a service that was taking all of our work and packaged it under this network as a service NAS umbrella. But the first theme of our NAS is this on-demand connectivity, which means everything's automated and the connectivity of buying, selling, connecting is all on demand. So you can change, have a very elastic capabilities across the ecosystem. So it is actually our first theme. And it also incorporates carrier Ethernet, but also wavelengths, because we also specified layer 1 connectivity services, which is really, at the end of the day, wavelengths have to go back to electrical domain, mainly LAN Ethernet. So that's very interesting. And what I think is really interesting to conclude this is your idea of AI is really powerful, because what we're seeing with AI is we're tokenizing the world. Just like, we digitized the world from analog to digital, we're now tokenizing all of the content in the world into tokens. into these large language models. And what you're saying is there's some of these large language models are holding 1.5, 2 trillion tokens. And they need massive amount of machines, like tens of thousands of machines to build these transformer architectural or these with deep neural networks, now it's transformer architectures. And when you're doing this training between all these different regions, you're saying it takes a tremendous amount of bandwidth and very low latencies. Is that what you're saying? Why you need the wavelengths and the 100 gigabit capabilities?
Yeah, I mean, I'm not versed at exactly what is needed, but from what we've heard, each of these AI data centers may have 2,000 fibers going in and out of it. And there is there's communication between the components of the AI models that require huge amounts of data. The latency element is certainly at play, and I think that's why you see Lumen selling tons of dark fiber. And if you think about a dark fiber strand, right, like you can put a lot of our dark fiber strand. You can put 10, 40 terabits over one dark fiber strand, many 100 gig waves. And these guys are buying 12 strands between, in 4 different directions. So the amount of data they need to move is pretty insane. And so, I think enterprises are going to have to interact with that, and we'll be watching how that drives some of that high bandwidth element. I think as it pertains to NAS, just more generally, we've seen carriers, they have old networks, lots of different networks, and it's very difficult to be, provisioned dynamically and offer services in a dynamic nature. And that's why organizations like the MEF are so important to kind of get aligned on the best practices, offer definition about what it means to be dynamic and what it means to kind of have the more flexible nature. I think as we look forward, there's going to be, as I said, potential for some more interest or need for some of that dynamic nature, just given the interactions with these AI models. I think that and then also a focus of carriers and something that really plays into this data center connectivity need is some of the really fast provisioning, particularly on those large connections. You've seen, Windstream, Zayo, Lumen really focus on enabling that. And so, that is a theme that is continuing. And I think the work by MEF really helps move that forward to share experiences and bring this industry around. We think we saw, SD-WAN kind of overlaid some of those issues, but as we look in bigger and bigger data amounts, there's going to be a driver to really fix and enable some of that dynamic NAS nature.
Charlie, what an interesting conversation. I could go on on this, and I think we've probably run way over. We're already a little bit over our limit, but what a fascinating topic. And I really want to thank you for being, participating in this episode. And I think our listeners are going to love what you have to say here. So thank you. Really, really fun time. And I'm so looking forward to the future of networking, which most people think it's just a pipe, but it's more than a pipe. It is really the fundamentals of how information is flowing. So again, thank you, Charlie.
Thank you.
Thanks for joining us for Executives at the Edge. Don't miss an episode. Subscribe today. Share online a review. Find all our episodes on your favorite podcast platform and at MEF.net.